Karthik sir. Karthik sir.
சொல்லுங்க மேடம்.
சார் வெள்ளங்கிரி.p ன்னு இருக்காங்க பாருங்களேன் சார், கெஸ்ட் பேனலிஸ்டா மாத்திடுங்களேன்.
என்ன மேம் சொல்லுங்க, திருப்பி ஸ்பெல் பண்ணுங்க. .p மேடம்.
எஸ் சார். ஜெயக்குமார் சார், சார் ஆல்ரெடி ஜாயின். சார் வெள்ளங்கிரி சார் மட்டும் ஜாயின் பண்ணிடுங்க சார்.
மேடம் நான் பேசுறது கேக்குதா? ஹலோ
சார் எஸ் சார், யூ ஆர் ஆடிபிள் சார்.
ஓகே ஓகே. How you are
Yes, you are
teaching?
audible.
Tell me how to share the screen.
Sorry sir.
How to share the PPT file.
Yeah sir, at the bottom of the screen you can able to see the share.
Okay.
Yeah, you please just click on share.
Oh, the file.
Yeah sir. No, at the bottom of the screen. Yeah sir, now it's screen is sharing. Yeah sir, we can able to see.
Here.
Yes sir.
You see the first slide.
Yes sir.
Oh,
It's
now.
visible sir. It's
that-
visible.
Okay. I had a video. Video was
Yes.
maybe if you have time, I will put the video at the end.
Yes sir.
Unnecessary confusion. The voice is okay. I have a mic also.
Yeah sir, your voice is well and good sir. It's audible. It's clear. கார்த்தி சார் சாந்தி ஹச்ஜே இருக்காங்களா பாருங்களேன், அட்டெண்டீஸ்ல இருந்தா ப்ளீஸ் அவங்கள கோ-ஹோஸ்ட் ஆக்கிடுங்களேன். சாந்தி ஹச்ஜே, சாந்தி எஸ் தான் இருக்காங்க. ஐ திங்க் ஷி இஸ் பார்ட்டிசிபென்ட். அவங்கள விட்டுருங்க. பத்ம பிரியா இருக்காங்க, அவங்கள ஆட் பண்ணிடுங்களேன். பத்ம பிரியா ஜெயராமன்.
ஓகே.
சாந்தி மேம் இஸ் நாட் எட் ஜாயின்ட்.
ஓ, நீங்க ஸ்லைடு பார்த்திருப்பீங்க. More of technical.
Yes. சார் சாந்தி மேம் அட்டெண்டீஸ்ல இருக்காங்க பாருங்களேன். சாந்தி ஹச்ஜே.
I'm inside the house, but there is some disturbance. It's in the main road, my house.
Good evening, sir.
Good evening, madam.
Yeah, welcome, sir. Shall we start, sir?
It's okay.
Okay. Shanti, you can start, please.
Oh, yes, ma'am. Okay. Good evening, participants and our distinguished guests. I'm Shanti, your host for today's session on innovative approach for developing industry-ready curriculum case study. This FDP aims to bring together the academicians from different universities who are responsible for delivering transforming employable education to the new generation students. It's an honor to welcome and introduce our eminent guest, Professor Vellingiri, a senior consultant of Tata Electronics. I would like to present a short profile of our speaker. Professor Vellingiri did his graduation from PSG, Coimbatore, and his post-graduation from IBITS Bilani. He served as the chairman for Quality Circle Forum of India, Hosur chapter, since 2015 to mid of 2022. He is a member of TQM Committee of Quality Circle Forum. He is retired as General Manager from Titan Company. He has studied and evaluated more than 1,000 case studies. He actively participated and represented various teams to evaluate quality process procedure. He is currently a senior consultant for Tata Electronics. He is a chairperson for a board of governors of Government College of Engineering, Salem. He is an instrumental person in development of new course, BSc Manufacturing Science of Bardiyar University with Tata Electronics. He has authored various textbooks for BSc Manufacturing Science and on urology. He is a visiting consultant for process audit at China. He contributed for Quality Circle Forum conventions at chapter level, national level, and was a jury for international conventions of Tokyo, Japan during 2019. We look forward for an interactive session from our participants. Now let's welcome and invite our esteemed guest speaker. Thank you and have a good day.
Thank you, madam. Can I start?
Yes, sir.
See, one small housekeeping points. Let's avoid distractions. Mute only when need to speak. Interrupt. I'm not using university curriculum jargons, so you have to understand. Most slides can be sad. Questions can be at the end. Somebody want to contact, this is my mobile and mail ID. A word of caution, I have vocal cord paralysis, so little difficult to speak loudly as they speak. So you have to be a little bit careful in listening to what I say. I'm not a professor, as they said. I'm an industry expert, but I also teach. Last 7-8 years, I was teaching mainly industries on problem-solving tools. It was a free service. Now I do for Tata Electronics. I was in HMT, Titan, now in Tata Electronics. HMT was 7 years, Titan 30 years. Involved in creating the curriculum for BSc. As I know, this is a new course. I don't think any other college has this BSc Manufacturing Science course. It is first time. I was also working for VIT and Anna University with them for another course. Any points irrelevant you can ignore. This is like a case study, like matching to the title. So,
Sir, sorry to interrupt you.
Yeah.
Yeah, we are unable to see the full screen, sir.
1 second. Now,
Yes, sir. Yes, sir. No, yes. Thank you, sir. Thank you.
so I was doing this last 2 days. 2 days. If there is a mistake, please ignore. I was in Titan. I said, this is an assembly. All women employees. Some of the topics covered, my experience learnings from watch industry. I learned many quality tools, problem solving tools from Japan, from the suppliers for Titan, industry experience, and my experience with new joinees, diploma and graduate engineers, technology trends, skills required, technology management, how to map the technology available in the companies to subjects. Then new subjects we developed, challenges, solutions. Then the syllabus, how did we create teaching and learning? This I learned from my 6 months training at Indian Institute of Management, Bangalore. One of the mechanical professor used to show this as first slide. This is from Sanskrit. 1/4 is from the teacher learning, 1/4 from the student himself, own intelligence, 1/4 peer learning, and 1/4 in the course of time means practice, test, model exam. The students won't practice. So I'm saying 25% from me for this session. This is one important quote from one of the quality group, from a Japanese quality group. He says as much as 95% of quality related problems in the factory, in manufacturing setup, can be solved with 7 quality tools. He says 95% of the problems can be solved. So we get this in mind. I also practiced in the company in Titan, also in Tata Electronics, also in QCFI. So this is one quote instrumental for developing the BSc course to incorporate some of the subjects. Another quote from one of the quality group: defects are not free, somebody makes them and gets paid for making them. Another quote from same Deming: only if you measure, you can understand. When you understand, you can control. So if you control, you can improve. Only if you improve, you can achieve the goal. This is one formula for success. This may be applicable for a student, for a professor, for an engineer, for a staff working in government organization. Have knowledge, skill, then practice. Have attitude to learn, have multi-skill, and also have motivation. Then the success factor is very high. From Steve Jobs, innovation differentiates with the winner and the others are mediocre. I believe the team working under him went with a market research study. Steve Jobs said, I don't want to see this report. He said, I want to create a new market. Customers may be existing, but a new market. So come out with a product which every customer want to use. So he changed just 4 or 5 products. He changed the company's performance. Some of the quotes: design is thinking made visual. Design is not just what it looks like and feels like. Design is how it works. Again from Steve Jobs. This we use in the companies. What customer wants is the bottom right one, but how the customer explain, what everyone understand in the process, then what they make. So what customer wants is different. So we need to keep customers in mind. For university, for purposes, student may be the customer. So we need to make what customer wants. Market scenario. Today, it is highly competitive world. I don't know for universities, but for companies, certainly yes. Competition is mouse click away. When a customer buy a product in Amazon, before placing order, he gets a comparison. So he may change to another make product. He has price comparison, also specification comparison. So competition is mouse click away. E-com is ruling the market. Product life cycle is shrinking. Not like Ambassador some 25 years back. The life cycle of Ambassador was more than maybe 30 years, but today not. Product life cycle is shrinking. Features and functions are unlimited today. A smartphone, the maker don't know how many features and functions because it depends on the applications. So it depends on the customer. So unlimited features, smartness in mobile, home, office, factory, cars, in many other products. Apple compete with its own previous version, not just other competitors. They started with many versions. Now it is 14, I think. I have 10. So it is 10, 11, 12. Every year, they compete with their own products, upgrade or come out with new functions, upgraded quality. Globalization. Actually, any country today, it is one-day distance. Miles may be too many, but it is one-day distance. You can reach within a day, US, within a day to Japan. So it is one-day distance. The products are coming from many countries. Low-cost product from China. The government is talking about make in India. War in Ukraine, Corona issue in China, there are a lot of opportunity in India. Chip war, just recently, 2 weeks back, between US and China, there is recession fear. So the only point is how we overcome with creativity and innovation. Manual, 10 years back, 15 years back, an operator in a factory used to move the tool post by hand. Today, no. CNC. So he has to only touch the panel, select the program. Robots are extensively used. 3D printing started by industries for prototyping, even for customized product manufacturing, used of plastic parts in automobile, injection molding everywhere. Electronic parts manufacturing is the new avenue for the country. Chip manufacturing is in the agenda. Precision parts manufacturing. Industry 4, Professor Jayakumar was talking about 5 also. Smart factories, right first time. Concepts. Smart cities. EV, rechargeable batteries are also on the agenda. This is how the product is getting developed. Today's smartphone versus the first phone, versus handheld phone, also the computer. The thicker, bigger in size, larger. Today, it is lightweight. Innovation is the act of creating new value to the customer in a way that the customer has not experienced before. Industry 4, it is changing mechanization to mass production of cars to computerization to cyber physical system. I had a video. If I have a chance, I will show an Industry 4 company how it is working. It is in a simple way, it is smart system of managing. A mobile can manage the factory, and application can manage. Sitting in front of a computer, you can manage a production line. So the cyber physical system of interconnecting the workstation to PLC and the communication and control systems. A smart city, I have seen in Hong Kong, also in Tokyo. Hong Kong, you have an octopus card, you can go anywhere. You can go to train station, it is exact timing. You can also go to any shops, you can buy anything, just using one octopus card. Similarly in Tokyo, the metro stations, Tokyo, entire country is 5S workplace managed country. Entire country. It is school, it is college, hospital, institute to industry, a public place, railway station. In Tokyo railway station, I was trying to take a picture to find a dust to show to the Japanese colleague who came with me. He was asking me what you are searching. It was an underground station. I said, I want to show you dust on the floor. I don't know how many square kilometer underground. He said, you won't find because it's a culture. So I could not find. So smart watches, smart mobiles, smart homes, smart cars, smart factories. Why not a smart course with smart teaching and learning? I hope I will be able to explain you at the end of the session. It is seamless integration of informations, machines, controls, predictive measures, preventive actions, not corrective action. Corrective action is after a problem occurs. Preventive action is before it doesn't even occur. There are many examples. I visited part of my Titan service work many times to Swiss, to Japan. Swiss, I was traveling with my colleague on a Sunday. It was on a Sunday. He got an SMS from a machine. The machine stopped. He said, we have to go back to factory, rectify, then again go for sightseeing. I was walking through one of the Swiss factory. He was showing a control room. I asked, what is this control room? He said, it's quality control room. There were 2, 3 engineers monitoring the computer screens. the graphs, online graphs, dynamic graph. When we were visiting, seeing, observing, one of the engineer called one of the shop floor man, your machine is going to create trouble after 15 minutes. Stop the machine, change the setting. So that is a kind of preventive action. It is quality 4, industry 4 kind of scenarios. So why not? In India, we have skill. We can also do anything. So opportunities in India, electronic manufacturing technology. Just few months back, Make in India program was launched. Also Make in Tamil Nadu by Chief Minister of Tamil Nadu, Make in India program by Prime Minister. So all of us need to align. It is not just industry. I'm saying also the education institutes need to align. Come out with new course or update existing course so that the course supports the manufacturing. It may be electronics, it may be precision parts or electronic parts, it may be EV. I made a statement, this graduates are not industry ready. This I made not based on my own perception. I met maybe thousands of engineers, graduate engineers, diploma engineers, also graduates, science graduates. They say we need training. If you ask a person to read drawing, he says, teach me for 2 months or 1 month. So we had many programs in the company. For graduate engineers, we have many companies have 1 year program. Post graduation, they have 1 year program. First 3 months with HR, next 3 months with technical training, next 3 months projects, the last 3 months hands-on with the division. So after 1 year, they are ready. They are saying, even I have seen in my own department. So our single point agenda is how to make the graduates, engineers, say the science graduate, if it is manufacturing science, industry ready. And this is again the industry opportunities. Global electronic industry 1.4 trillion. India for 200 billion US dollar by 2025. That is the program. So we have a lot of opportunities. New industry in India, speed up change. Competition is well established. We also need to establish highly cost competitive. Focus on quality, capability. This is about just one slide about Tata Electronics. This is in line with Make in India program on electronic parts. They make precision parts. They have aesthetic finish. This we call it as cosmetics, product finish cosmetics. We introduced a new subject for the course we developed with Bardar University for BSc Manufacturing Science. We consider the manufacturing. We try to align 100% for all the manufacturing quality and inspection. 90% of the jobs for women, for them we developed this course. Also, they are from poor background. If there are 200 industries in Hosur, 199 industries for male employees, why not one industry? It is Tata Group initiative with the support of governments. So we try to support for the education also. They work, also learn. It was a work integrated learning program. So Make in India, Make in Tamil Nadu, Industry and Institute to support this initiative. Outcome of this initiative from Tata Electronics and Bardar University is to develop a new BSc Manufacturing Science course focusing on manufacturing. So the manufacturing areas currently in the country is focusing on mobile. Mobile, there are no manufacturing units. China is considered as manufacturing hub. So the customers are looking at an option. So India was considered as an option and the government is looking at to use the opportunity. Mobile phones, electronic components, healthcare, industrial electronics, IT hardware, consumer, automobile, EV, I must include PCB. So we try to match whatever the country wants, whatever the company is doing. So why not a new course so that people work, also a work integrated learning program. As I know, BitsPlan is doing, some of the other, I think software companies are doing with the universities. So it's a similar course. So first time this course, this is only an FIR. I will explain in the subsequent slides. Cosmetics is a new subject. It is visual inspection. So there is no book. Normally, when we look at syllabus updation, we look at in the net or colleagues any similar subjects. In our case, we could not find for some of the subjects. So you have to create new syllabus. So we created a syllabus for cosmetics. Normally NDT is part of the syllabus, but we included both the destructive and non-destructive reliability testing. Problem solving tools, I referred to Quality Guru Karu Ishikawa. 95% problems can be solved by 7 QC tools. So why not problem solving tools and techniques? This is not just engineering. Any problem solving is required for a person working in municipal corporation, working in pollution control board, working in any railway, working in any organization. They need problem solving tools and techniques. So statistical quality control, we introduced laser technology as a subject. It was considered for one area. Now it is for cutting. Also laser, it is applied as per the application. It is for cutting. It is also for joining. So we use for joining. Sensors for automation laser. Sensors are used for quality checks. Sorry, it's a laser scanner or is missing. And plant internship we introduced for 5S workplace management. Some of the pictures I will show. 7 QC tools, lean practice, not just for engineers, not just for a postgraduate engineer, not just for industry. It is required. 5S workplace management required everywhere, for a railway station, for a government office, for public places, for an institute, for an education institute. It is required. I've seen in hospitals they follow. I've seen lean practice followed in an eye hospital in Bangalore. There are 6-7 rooms. The patients go in sequence, 5 minutes. The last is operation, then the next is counseling, medicines and advice. They go out. It was in a sequence. So lean practice can be used even in a college, engineering college or a science college. Kaizen can be used everywhere. I have seen entity of students making a Kaizen presentation. 50 slides. He has not seen, the student has not seen any of the slides. He only saw what slide he started presenting without reading. We also introduced workshop practice labs, considering the thousands of machines. We have in an institute, you have the constraint. You may have a sample machine, but in the industry, it is thousands of machines. I don't know how many machines Tata Electronics they have provided. It is more than thousands. CNCs, milling, surface finishing, injection molding, anodizing, laser welding, many quality control machines. They have hundreds of CMM. I have never seen such machines. It is first time. Maybe Tata Electronics is first time manufacturing the mobile parts for a high-end customer. So far, there are other companies established for assembly. This is for manufacturing. So they have so many machines. So what manufacturing want in a highly competitive market? They have to be lean and agile. Engineers, graduates, science graduates need to have high level of creativity and innovation skills. The company wants flexible workforce, high level of knowledge and skills for solving problems. Industry ready engineers, staff, graduates with high level of communication, knowledge and skill. What they come out with qualification is excellent knowledge on the particular branch of engineering or science. They are more theoretical. They have practical, but this I'm making in the context of a customer as a industry person. They are less on practical. If we ask an engineer, can you operate the CNC? He needs some kind of training. So I said almost 3 to 6, 9 or 12 months we give based on the kind of technology and the precision. What we need is communication, presentation making, project principle. Professor Jayakumar also is listening to this. He was my mentor for developing the course. But in the English, he introduced how to make a proposal, how to write, how to understand a standing order, how to communicate in a company, how to make a presentation, teamwork, multi-skill, soft skills. We need problem-solving skills, 7 KC tools, lean practice, Kaizen, continuous improvement, creativity and visual management, quality, productivity focus to improve continuously productivity. We don't have a standard, continuous standard like Ambassador 30 years back. No. Today's standard, the customer is asking to change. The level of productivity will change next year. Today's technology, it may be 100%, 80. Next year, they will level down to 70. They will ask to increase to, the base will change. We need to continuously improve because the competition is changing. Control charts. I said a Swiss company was indicating to the production man, online dynamic display, the control chart. He was predicting it is going to change. The machine is going to produce defective part after 15 minutes. So they change, stop the machine and change. So the engineers should know the control charts. They should understand how the machine is performing. Safety aspects, workplace management. Learning, above all, a learning attitude. Learning is continuous. Continuous, I had the opportunity to learn a part of my working at Titan, also Tata Electronics. Many learning. I was deputed for a 6 months course in Indian Institute of Management, Bangalore. The learning practice improved after the 6 months course in Indian Institute of Management, Bangalore. They don't close the library. Only 2 days the library was closed. It was for national holidays. Otherwise it was open. They don't close. So they crash program of MBA for 6 months. So they made us to study many books and learn. I learned lean practice there. The people, the students should have a growth mindset to embrace challenges, train the brain. Effort is a path to mastery. Learn from feedbacks. It is not no more individual. They may work individually, maybe in a software company, but even there they may have a team, but they may work individually with a computer. But in a manufacturing environment, it is a team. Even in an office environment, it may be a team. So inspired by success of others, to learn from for me as an engineer, it is learn from quality groups. So inspired by many quality groups. For us, the quality groups in the manufacturing for quality are Deming, Juron, caused by Ishikawa. There are 13. I was told to add another 2. I did not have time to add. It is from Toyota production system to quality. Deming and Juron helped in Japanese to improve the quality. The quality improved post-war situation. They were wanting. It was all customized. Parts were selective parts. So they wanted standardized. Any product, any part, they should be able to assemble. For a product, any part produced any day. That is how the standardization and quality came in. So all of them are, each area, there is one groove, PDCA, we adopted for developing the course, zero defects, cause and effect from Ishikawa. He only said 95% problems can be solved in an industry if they know 7 Kishi tools well, how to study, how to understand a problem, how to project, analyze, brainstorm, and solve. Cases, single minute exchange of die set to reduce lead time, 6 Sigma. 6 Sigma may be higher order. Brainstorming, DOE, we consider as little higher order. DQC, modern graphical method, 5S, workplace management. Most of these trainings were given in the companies. So why not partly the institutes? I think they have started covering Lean, 6 Sigma. In fact, whenever I conduct interview for engineers, I don't ask the subject at all because they are well taught by all of you. Knowledge sharing is godliness. I appreciate all the professors who taught. So whenever I interview, I ask any books other than the textbook you studied. If somebody says gold book, Toyota production book, 6 Sigma, I simply select that candidate because of his learning attitude. So we also look at these kind of tools. This for time, I will try to skip this. We follow in all case studies, plan, do, study, act, plan, do, check, act. It is to define the problem, how to gather data, analyze, then identify, find out the solution. We have many methods to find solutions, starting from brainstorm to design thinking. Then check, act. There are 8 dimensions for quality, all from quality grooves. I remember even Professor Jaykumar used to talk about that. I added 2. What are additions? This is considering the smartphone. Safety. Any product should have safety aspects because there are many unsafe conditions issues. Also today the features, even the manufacturer don't know. For example, Apple don't know the kind of features the customer will try to use because it depends on the applications they download. Applications use the sensors in the mobile. Then the number of features are much more. So it is not 8, it is 10. We don't know, it may be evolving. So the quality dimensions are changing. One of the quality tools which we use, I use in Titan. If there's a failure in watch, so quickly we check this. There are joints, design aspects, people. So can we check? So which one caused the problem for taking? We standardize the chart. So the engineers or diploma engineers, graduates or science graduates, they should know how to solve a problem, how quickly to analyze the causes, find out the causes, find out the root cause and do. These are some lean tools. There are many, but selectively we can try to teach 5S. We teach in the company, well, VSM we teach, layout we teach how to improve, part of lean tools, Poka-yoke, and just-in-time concepts, how to set up the machine quickly, machine setters, we teach them. So how to have full system just with a card. Japanese use a Kanban card for full system. We selectively apply and teach. There are many 6 Sigma tools. This was conceived by Titan. Tighten and up. They have many tools. There are hundreds of tools. I learned from a book from a Japanese when I visited Chusei, Japanese Union of Scientists and Engineers. They have a book tools useful for task achieving. There are more than 100 tools, but every tool is explained only in 1 or 2 pages, not too many texts. It is visual, charts, easy to understand methods. They have listed 74 tools, which is applicable for a Titan is a precision industry. So they were using 74 tools. It is on all angles, 7 key tools, 1 branch. To reduce defects, Six Sigma concept. There are most of the companies have plus or minus 3 sigma. That means for a million, they have 66,810 defects. They do rework screening. They use the waste resource. So they need to change. There are some low hanging fruits, which is generally from simple tools, simple concepts like 5S, Kaizens, TPM for managing machines. Even in TPM, there are 8 pillars. I want some 2-3 relevant to start with, then other. Lean Kanban system is Six Sigma at a high-end level because it contains many high-end tools. So we select and apply, adopt. So even for a educational course, for the course we selected some basic tools and adopted. Some of the quality tools. It is graphical representation, simple concept. I brought some 7 charts from Jusei, Japan. Each chart 2 page. That's it. 7 key tools we can study, be thorough in 12 pages handout from Jusei. So they explain in simple terms. Pareto, scatter, control charts. Company need to use scatter plots, 2 variables. So how do you relate? Is it proportionally, it is increasing or declining, or increase and decline over a period of time? If you understand, then you can easily solve the problem. So control charts. Only this control chart I was saying in a Swiss company, they were using. They were predicting the machine behavior. Then they were advising to prevent the defect, stop and change the setting. Sorry, I keep drinking water. Flow charts. We ask engineers to make flow charts for a process. If they come out with a problem, we ask them where it is. So they need to understand. Simplify, so explain cause and effect. For a problem, what are all the causes? Then discuss, brainstorm, find out the root cause. Histogram, stratification, checklist, check sheet, brainstorming. The company we saw for Poka-yoke, if they say repeat problems, can we improve, introduce a Poka-yoke system? They should understand. So it is there in this, the point. So only it will enter one side. So it's easy. So it can be on visual aids control fail-safe method. It is introduced for electrical system, electronics, also in machines for setup. This is for any manufacturing process. The first line is the current state. Current state is the current status. They will have many non-value adding sequence. There is one video also. Many value enabler. Value enabler is QC checks. Value addition is the actual value manufacturing job which a customer will pay. So there are 3 components. If you see total lead time is longer because of more non-value adding time. All the red are non-value adding, blue value enabler. It may be setting setting the piece on the machine. So it is value enabler. Otherwise, we cannot produce. But the formula is how to reduce, eliminate non-value adding, reduce value enabling, optimize value adding, so that we will come to lean state. The future state is lean state. Less of red activities, more of green, so that it is manufacturing. I have a video, a project done by me also. So formula is eliminate non-value adding, defects, rework, moving, wasting time, reduce value enabler, quality checks. Why not write first time? Optimize value adding. This is not just for manufacturing. It is for educational institute. It is for an hospital. It is for an government agency. They do, banks have done. You need not go to bank to open the account. You need not go to bank to transfer money, to deposit money, maybe ATM or in the mobile. You can transfer money. So they're changing. In a passport office today, it is faster. They allocate time. It is in a sequence lean practice. Stage 1, stage 2, stage 3. You come back from the place, next day you get, in 2 days, you get the passport. So why not even other agencies to improve? The 7 wasteful activities. This is sin, crime. Moving material is crime in industry. High inventory is crime. Overproduction. Muda is all wasteful activities. Over processing. Rework is wasteful. So we ask an engineer to study in a process what all wasteful activities, how to reduce wasteful activities. Can you audit the process? Come back. For each activity, element-wise timing. So it is their job. So we do this. I will show with a simple example. And more of visual communication we use in the industry, because the cycle time for me in Titan, I was asked to produce 50,000 watches in 8 hours. The takt time is 0.5 second. So I don't have liberty to lose. So I don't have liberty to have all wasteful activities. So I have to reduce wasteful activities, focus on. And just one, for jokingly, I used to say this. I was watching a movie in a cinema theater in Hosur. I'm speaking from Hosur, where the Titan factory is located. I stay in Hosur. I was watching a movie at 6:30 in the evening. It was 20 years back. The movie was stopped. There was a slide. Those days they used to put slide. I don't know now. They stopped the movie. Then the slide, they said they called me in Titan as PVC. The slides was saying, PVC, you're called back in factory. Please go back. So when I came out, there was a car waiting for me. They said, you have a job to do. Please come back. So it was crisis, because those days we had MOS method. So I had like that many troubles. So it was not trouble, it's an importance. Also move from mass wasteful activities to lean activities. Then the last 7 years of my service, I managed high volume without any crisis. So that's why I'm referring that example. One video just to show what all wasteful activities we have everywhere in the country. It's a simple video. It's just making toast video so that a +2 operator can understand, a science graduate can understand, and diploma engineering. Making toast video, you can study how many wasteful activities, what customer wants, what it does. In a restaurant, she's searching for bread. Customer was talking to her. She did not even listen to customer. Not in the bread in the toaster. So walking is wasteful activity. This we saw to teach lean practice. A simple video. Comes back. Switching on the toaster. There are 8 bread slice. Is waiting. Waiting is waste. Moving is waste. He has not prepared the plate. So now she goes to bring the plates. Again walking. I have a question to all of you. Maybe chat box I cannot see. The organizing team can see. There are 2 options to reduce wasteful activities. So defect or processing. At the end, there are 2 fish for this. What should be the layout? What is the best option? So any of you can answer at the end. So rework, it's wasteful. I used to ask what should be the layout so that reduce the wasteful moments.
No,
She's talking to the customer.
hey, about the,
I got it.
about the,
I got it.
Customer is trying to explain. She did not listen to him.
really, about the butter.
No, I got it.
Walks again, bringing the plate. Dropped. Finally,
Right, still really about the butter.
the customer is saying, I want what he wants. He's applying butter.
Hey, here you go.
Right, one piece would have been plenty. I really wanted jelly on it.
So what customer wants was just 1 bread. The percentage of wasteful activities, I want to pose a question to you. Maybe at the end, any of you can answer. The percentage wasteful activities, the percentage value addition. Then what should be the layout? What customer wanted was 1 butter, 1 bread with jelly on it. What she made was 8 pieces. Oh, everything was waste. So in the company, we call it as 5G, Gemba, Genbutsu, Genjutsu, Gendi, and Gensuku. It is real place, go to place, look at things find out the real facts, understand the principle of operation, what is the standard and parameters they should try to improve. I made one project considering that a lean practice. You can see the kind of valuation. Is he wasting time or only valuation? Conveyor is moving parts. There is zero movement by the operator. Operator is picking and assembling a screw using a screwdriver. There is synergy. Cycle time is 1 second per piece. If there are two operators, it is 0.5 seconds. So it is 50,000 per day. Mostly 95% valuation. Maybe moving the screwdriver, part is very close to job. I've seen in many companies, job is they move, they go, walk. This is to example for a non-validating quality checks and validation doing right first time. RFT is right first time. NVA is quality checks, but it is value enabler. The right side picture is showing right first time concept. The production operator is saying, you give me a CCTV, I will check myself. Checking for hands. 3 operators were assembling, 4th operator was checking. There were conflicts. So the production operator said, give me the TV, I will check myself. So it is right first time. So it is right first time concept. It is reducing setup time. It is focusing on lean practice. It is solving problems using 7kg tools. There is one visual in the recent past, more focus on visual inspection, where I should not show the mobile because of confidentiality. So it is a watch component is general. It is not from Titan, other companies in China. So visual aspects, part which is worn on hand. So everyone will see. The customer may not find out, but the inspector will find out. So this is more and more required in the recent past for the products, for the mobile or watch parts or the any other product which is worn for jewelry. So this is more important nowadays. So we developed a new course on cosmetics inspection. All these I'm showing as design thinking process. First process is empathy. So we need to understand the stakeholders, what they want, what they do, what customer wants, which is the pain point. So which are all the area we need to address. But this is one of the aspect part of the new curriculum development. We look at all this. So that's why I'm showing all these practices followed in manufacturing. The challenges, pain points, issues, improvements made. So this is one visual inspection. There are many. It is the look, the color, it is finish, it is scratch. So there's an impression. So it is defective. So they should look at the printing quality, printing marks. For a watch, and there are more than 80 inspection parameters. They are given only 30 seconds. I had a video I should not show, not shown, so because it is actual video. 30 seconds, they should check 80 points. So it is any product, it is the shortest time they should check. So cosmetics is one key critical aspects for companies. So we introduced that in the course. Lean practice 5S. Visual, this is scratches, polishing, the gap, assembly rejections. So we incorporated most of the visual points, hundreds of visual inspection points in precision parts. It is not just for Titan or Tata Electronics or It is not few companies. It is more and more the product handheld the customer will wear or look at. So this is important. The 5S workplace management is, we thought it is important. It is important for an hospital, for an education institute. I went for a training in an institute in Chennai. I couldn't find that department. The department I have to reach. I took more than 15 minutes because there were no signboards. There were no displays. So it took time. I have to ask everywhere, then find out. So 5S workplace management is good for, I was told, in fact, my training on 5S lean practice for polytechnic principals, it was for non-Model 1 scheme. Our government introduced this training for entire polytechnic students as part of skill development. 5S 7 KC tools, lean practice. So I was a trainer for, it was a training for trainers, for polytechnic faculty members. So I did this. Whatever I have shown, I did most of that. So 5S is important for an engineering. I said I have shown a assembly video for 1 second. So if they are searching for component, 1 second is not possible. So 5S is critical. There are 5 steps. I don't want to explain in detail. So we used to teach. This I took the picture in an educational institute where they want to implement 5S. They want to improve. So it is not for negative, it is for learning. So many documents were on the floor. Difficult to, how will you take document? As per 5S norms, 30 seconds target time you should retrieve any document. It may be a book in the library. Library is best example. But a library in the staff room, they took more time. They took more than 3 minutes. They don't know where was the key. Oh, it was with whom. So the key doesn't have a label. So they wanted to improve. See, this is a shoe rack in front of a lab. The racks are empty in the rack, but the racks are empty, but the shoes were kept on the floor. This is in a lab again. The cable is crossing, so it is unsafe, very, very unsafe condition. I know Chennai Silks incidents was because of loose contact. So 5S can save crores and crores of money. This I saw in a company. There are hundreds of files, documents. This is from 1986. Till now, they have the records. Part of 5S certification, I go to this company. Any file I ask, without if the person is a little away, I check the file, ask, they trace, take it in 30 seconds. Any document for 30 years, more than 30 years. So document retrieval, electrical switch. I've seen in places, if you want them to switch on, trial and error in the switch on, if there are 10 switch, all 10. Not for fan, not for light, because they don't know. So labeling, it is part of 5S. A layout is part of 5S. The machine operating condition is visual chart, part of 5S. Where to keep the equipment, where to take, it is a 5S practice. Very, very safe. Visual instructions to keep material. In airport, they follow. In Japan, entire country is following. I could have visited more than 10 times. I've seen, I learned from them. They don't put, last time, 2019, it was a international convention in Japan, Tokyo. 8 of us were in bullet train. The person from the watch company was with us as guide. He said 2 minutes, the station is going to come, get ready. So we were given some eatable items. He wanted to keep it in the front pouch. He had a bag with him. He said, please give it to me. I will put it in the bag, put it at the exit point. There is one big dustbin. We will put that. We asked him why. This is also dustbin. He said, in Japan, we don't, as a practice, we prevent. 5S workplace is to clean, maintain, also to prevent, so that you keep clean. This was a surprise for us. We said there are people coming in cleaning. He said in Japan, elders are coming, given that job. We want them to walk, check. Walking is an exercise for them. They will maintain their health. We don't want them to clean. Let's clean ourselves. In the flight nowadays, the air hostess come and collect. So the flight changeover time is less. Earlier it was in hours. Now it is 15 minutes. People are leaving one side. People are entering from the other side. It is 15 minutes. They change over time. So 5S, and they do part of this. See, this is an industry. The same shoe rack. Nothing is below. They are not kept outside. The steps, when you go up, it is one side. When you come down, another side. Where to keep what? So place for everything, everything in its place. Peep, first in, first out, 30 seconds, retrieval, heavy item at the bottom of the row, rack, light item at the top, chemicals with the labeling for self-life. It is like a human being with a card, identity card, no unidentified materials in a factory. It may be applicable for an institute also. So when the door opening side, so that it is there's no unsafe conditions. Car, you should park the way you have to take the car, pick up the car, not the other way. So there are conditions. So we wanted this as a subject. We introduced this as a subject because the industry wants. This is one problem solving method. I took an example. This is how they define the problem. Whatever they defined in the sketch or the image. I have seen thousands of case studies in the last 10, 15 years. I've seen some companies writing text. The same explanation, they write in 3 pages. How to understand the problem. What is the problem they define in hundreds of texts, writing pages and paragraphs. He is saying land width is less. One side it is more. This is a watch back cover. One side the land width is more, another side is less. So it is butting. Back cover, watch back cover is butting with a case center. So he is saying it is not uniform. Inconsistency leading to problems. So he wanted the land. So he has shown bottom left in the picture form. The center is the land, an enlarged view. So this land width is not uniform. He has seen, shown, explained with an assembly condition, case center on the back cover. This is in the watch. So it is not able to, but the butting is not uniform. So the problems will be water resistant property. It may fail, the back cover may come out. So the gasket may be visible. It may get damaged. He's saying 360 degree, it is not land, but it is not uniform. So simple way of explaining, it is easy to define the problem, easy to explain, present the slide to a team, and with the problem, if it is well defined, the solution is easier. So the non-uniform land, they also show with a good part. So this side is uniform. So this is the way we want. So this is a problem solving case study. My title also explained through case studies. So more of visuals. Purposely, I don't want to use the text because this is in continuation to, you can consider this as a continuation 2. It is like Ponniyin Selvan 1, 2. This is 2 to Professor Jaykumar's presentation. He made few days back. So more of visuals in my case. He spoke more of curriculum. It was an excellent presentation with few slides. He is my mentor for the development of this course. So they improved the die set, the radius they change, they solved the land problem. So this is a simple method, ECRS, for creative innovation. Most of the industries use. Eliminate, combine, rearrange, simplify. This is one tool we use. This is design thinking. Recently, I saw in a case study presentation, customer empathy, challenging questions, believe be automatic connect with the stakeholders, ideate, create, validate. We also part of design thinking we did. We were trained, few of us, even for developing this course at the company, by the company. Please empathize from the stakeholders, understand with customers, suppliers, stakeholders. It may be an organization or outside organization. Empathy. See, the problem will appear what you can't see. What you see is symptoms, but what you can't see is below the left side. So this comes out in the first stage itself if we properly do. So all this I have shown in the form of slides, the problems expressed in the companies. So what they want from the graduates, engineers, diploma. So they also follow in the recent days this design thinking. The first stage is empathize, that is more critical than defining the problem I shown in a case study for land for a watch back cover. Then ideate, I have shown on method. There are brainstorming, there is ECRS, there is Scramper, there is innovation, many methods available. Then the prototyping. We followed this even for the course curriculum development. We made the first level shown to all the HODs, a few professors. Then they gave feedback, then we corrected. This I also learned in Swiss. Every year when we go for an industry fair, they show new products. I ask them, how do you make? Every year you show, you have fair, industry fair. The equipment they show new. For watch industry, there is for precision industry, also for many other industries. They have dedicated fairs. Their simple answer is, we don't make. There is an institute nearby my industry. I gave the problem to them as a project. The students do. Then they give me a prototype. They give me the circuit. I only do industrialization. Again, I make another proto, second level, a working proto. Give it to Omex. Suppose if it is watch industry, Rolex, Omega kind of industries. They test. They give feedback. They improve. Then go for mass production. So it's almost like a design thinking process. We also adopted. This I learned from a case study. They also adopt as an what we did was science. So there is engineering, science. As I understand, when we started talking about manufacturing science for the company, I was looking at in the books, very old books. I found it very difficult to get a book on science. Then with the difficulties I got from my senior in Titan, it was from 30 years back, science book. And then the skill process. So it is all. As I think from science, engineering emerged, from physics, electronics emerged. This may be my view. You may have a contradiction, but it all started from science. So they develop a product. So this is empathize with customer, how to develop or correct their input, feedback. Then they define with expert panel, broader view and expert view. Then the analysis. Then they find this is for a jewelry product. They adopted design thinking. So they say this is easier. This approach helped us. They learned from the fruit. The inspiration is from a fruit. We have inspiration for jewelry making, for the grain orientation, the inspiration with Mysore Pak sweet. So the inspiration can be anything. So for watch part, curing, they adopted from a bread toaster. So it is from the inspiration can be anything. So they adopted this shape so that the diamond size is less, but the look is same. The first look and the last pyroform look is same for the customer, but for them it is lesser size. So ideate, implement, design, they adopted this form. So they test, they adopt CAD/CAM. This is an engineering solution, but the input is from a science point of view. So they might have applied CAD using CAD/CAM. So the design part, there are various levels. So we have job roles for a science graduate, for a diploma engineers, for an engineer. So we developed this course, BSc Manufacturing Science, a new syllabus curriculum for BSc. But we learned from all these case studies through design thinking process, understanding how case studies or problems are defined, how they ideate, how they make prototyping. So the old method, the new one, they interact with customers, understand, and they interact with makers, suppliers in the manufacturing process and with the customers. So it is 360-degree feedback. I was told for bullet train, the feedback was given by a team member from accounts, finance. He said, if you want the train to go faster, the engine, you can connect engines for every bogie so that it will go faster. That's how the two engine concept came. The train, the customer want to sit in the direction of train moving. So in bullet train, the seats are changed in 30 seconds. In 30 seconds, the bullet train, the seats are changed. One person walked through only to check, just to confirm. So the implementation training, they did across. So there are hundreds of problems in factories. This is also part of empathize. So pain areas in manufacturing, we also studied. So what they want, we understood. So we incorporated this Kaizen as continuous improvement. Workplace management, lean practice, 7 key tools, as statistical quality control. But we used both industry experts, also subject experts from the college, from the Bardiyar University, also friends across. There are people to share knowledge. Sharing knowledge is godliness, all of you do. It is a great service. So we learned from many colleges. We sat in PSG High-Tech library. We asked the librarians, can you give us books for this? But we don't want high-end books. We want the books most frequently used by the students. The librarians, the professors were not knowing. The librarians staff gave us 10 books. All were most frequently used. There were seals, 2 pages, 3 page seals. So we have referred such books. So it was more easier for us. There are myths. These rules are applicable only to companies, not for colleges, not for organizations, institutes, educational, or hospitals. It is applicable everywhere. I know case studies are presented by hospitals, case studies are presented by engineering colleges. Most of the the national conventions, chapter conventions of Quality Circle Forum of India are conducted in colleges. So I know in one of the college in Coimbatore, the principal came and sat with me as a faculty, as a jury member. He asked questions. He asked all his professors to sit through and understand the case studies in all the 40 rooms. So there was learning. Also in Hosur, one of the college, they asked all the professors to be part of team members. So they listened to all this. So it is applicable everywhere. It is applicable for hospitals, institutes. I referred to one of the presentation done by NDTF student. But it was, I gave 90 mark in my evaluation. He has not seen the slides at all. He just saw a fraction of a second, explained. Whatever I explained, he explained the process of case study, defining the problem, analyzing the problem, finding the root cause, finding the solution, proto-trial implementation kind of thing. The institutes are even certified for 5S. Educational institutes were certified. One institute in Hosur is in the process of certification. There are many examples for these practices. So why not? So this is the map model we adopted. What are all regulations for curriculum? The Bharatiya University team, Professor Jay Kumar, I used to take care of this, guide us, and they put us on the track. So we understand the current syllabus, curriculum. The company wanted manufacturing science. So what is current trend? I explained. Then what is the gap? For the identify the gap, then we did a mapping. We used academicians, also subject matter experts and the company's friend circle. We also tested this. Though we made for a company, I studied in PhD Tech. We have an alumni. They work big three. Now it is big four. You know, so it is Tata Electronics, it is Titan, it is Ashok Leyland, it is TVS. There are many MSME friends we have. We also tested. I explained to them. We got the feedback from the academicians, from the experts, checked, made the corrections. After the feedback, we improved. The improvement is every 1 year. So we keep improving. So this is the method we followed for. So it is in work integrated learning program. Whatever regulations we followed, look at the trends, the current syllabus, it is not matching. We developed a new course. There are some subjects not available. We created, then developed this course, adopting this model. But for innovation, it is PDCA. It is design thinking. Many problem solving tools. See the core subjects, the highlighted portion is the core manufacturing. So for the core subject, what are all the core and the manufacturing process? What kind of subjects? So for these subjects, what kind of prerequisite? Basic. So it is 4 verticals: fundamentals, basic, core, quality, then advanced, futuristic. That's all. 4 verticals we identified subjects and matched to develop the course. It is previous one. It is this slide, the model. So we kept this manufacturing, we mapped the subjects using all those slides I explained. So the bottom is what are the company tools we need to adopt. So we also try to incorporate. If it is engineering, we used Industry 4. For science, part of the subjects. For engineering, high-end, Six Sigma, Industry 4. Even in science, 1 unit for lean manufacturing, 1 unit is on Six Sigma, just basic concept. But for engineering, it is more on also Six Sigma. So we did a mix and match, and depending on BSc Manufacturing Science, BTech Manufacturing Engineering. We used high-end design part to engineering, advanced tools, advanced subject for engineering graduate, more of middle level, low end for BSc Manufacturing Science. So the new course, first time Manufacturing Science, the last two slides and previous slides, how we found out the tools required, then the two models I explained we adopted. So first time this course, first time cosmetics as a subject, problem solving tools and techniques, a book from Quality Cycle Forum of India we introduced. This is required for every companies. So why not for all science and engineering graduates? Laser technology advanced we are using for cutting. Then in the company we are using for joining. We are using sensors for automation. There are sensors for quality checks, laser scanners. So why not one subject? So plant internship. As part of plant internship, we introduced 5 or 7 keys tools in practice Kaizen, workshop practice labs, because we have thousands of machines. This is part of design thinking which we underwent. We are also adapted for this development of this course. Oh, sorry. I'm close to another 5 minutes. I will close. Part of design thinking process, we were taught how to develop. So this is a syllabus. This is a handwritten syllabus for a new subject on cosmetics. I will quickly run through. We found it was highly challenging because the company experts from US, from China, from India, many experts from other companies we interacted, took notes. Then I tried to develop a new syllabus for a subject on cosmetics. So level 1, level 2, this is for reliability, all handwritten. Then we try to develop a level 1, level 2, level 3, prototype 1, 2, 3. It is not, it is considered as a product on this syllabus, like a product for manufacturing. There are no books. So the company said, there are no books, then what? You write a book. So we are using 3, 4 experts write. They said, we want this course. We want this subject. So you cannot say no books. So collected feedback, Gemba walkthrough in the shop floor, then we created. This is the slide from Professor Jaykumar, moving from teaching, learning. We also adapted for teaching more visual charts, not just textbook. Even in the textbook, they wanted more visual. So this is one textbook, one learning material. I think only for this. I will. See, this is a learning material, a training material used in Swiss watch industry, horological institute. Swiss has many. This is a learning material given for the students. You can turn and see the watch. So it's easy for the professor, easy for the student. He can see in different place. How a watch works. Our spring works. Our watch. It is a hairspring in a mechanical watch. This is free shape of a hairspring. So when it is fully wound, it takes this shape. So this is the main spring in the mechanical watch. So when it is fully wound, it is like this. When it is assembled, it is like this. So the person can learn quickly. This is a part. Our gear works in different gear ratio. If it is 1:1, 2:1, 1.2. Our watch works. Our escapement work. Escapement work mechanism in a watch. This is a learning teaching material developed by Swiss. They have many horology school. Anything about time measuring instrument is horology. I also wrote a book. It was published in Hong Kong. Our hairspring in a watch. It's less time, so I will skim this. Our escapement. It is an interactive material. This is a visual paucity of time. I skip that, but I can share later. You can see entire watch. A student can, it is a self-learning teaching. It is interactive. Student can play with the material. He will understand 1 month teaching, learning is made within maybe a day or 2 days. You can understand a working principle function. So I call it as a lean teaching. This is a visual display we adopt in companies. Employees need to understand, a student need to understand what is the visual mechanism. Yesterday target, today at 9:44, 1301. So what is actual? So this is Mura Muri. 7 waste we saw in the video. So we use this for teaching. This is an earlier days we used to see this kind of learning material for school students. We adopt for teaching 7 waste. So easy for them to understand. We use the quiz method for teaching. So we saw quiz for 7 quiz tools for lean practice for 5S. We have quiz method of teaching, learning. So the answer they understand in the process. What is this? What is for to chart? This we use for teaching lean in a minute. What is lean practice? What is MOS? The first one is top one is MOS. The bottom one is lean practice. 4 pieces are done. So in MOS method, batch production. So they keep doing. So somebody next process is waiting. So lead time is longer, more inventory. Very easy to teach. I use this part of non-motherland scheme for train the trainer for training the principals of Polytechnic faculties of Polytechnic in Chennai. Use this. Just 3-4 videos, milk roaster, 1 case study which I did, then these 3 videos, then quiz. They are able to learn what is cause and effect for a copy note testing good. Very easy to understand. Then visual chart each Kano model customer delight. This 4 individual slide I combined for quickly completing the session Also difficult for me to speak more because I have vocal cord issue. So each one tool, one page. It is visual charts. This is the method in the company we use. This is one. Another, I think I'm coming to the end. And it is to conclude, understand the current trend, involve stakeholders, identify the gaps, introduce or update subjects courses, adopt various teaching and learning methods, create new standards. Don't go by what is already available. So if I know we interacted with many colleges for the courses, maybe 5 to 6. There is someone saying this subject is not there, but we say we want. So we want something new. So the products are not there 10 years back, 20 years back, a smart mobile. Today it is there. So everything is smart. So why not a smart course, smart method of teaching and learning? So accept change, update. If it is not available, create new. Use SMEs. Now, I think even for teaching, there was a recent guideline for using SMEs. So it's easy. Apply learnings. So explore multiple options. Thanks. I think it is coming to an end. I thank Tata Electronics, also my previous companies, for giving me opportunities to learn from Swiss and Japan and many other countries with experts. CHRO of Tata Electronics, he was in TCS before. He developed many courses for TCS. So he was put a lot of, he gave a lot of input, guideline. Also, we thank the industry experts. Then the coordinator Jay Shankar, Bharatiya University team, and Dr. Vimla, director, Professor Vijay Kumar, coordinator, and Ratnavil. And Jay Kumar, Professor Jay Kumar was our team member. I have not, by mistake, I have not included here. He was from the beginning our mentor. He was in part of Bharatiya University, also part of Tata Electronics. I met University VC director, Dean and the coordinator. This subject anchor to all participants for active listening, for the patience. I give most respectable job is teaching. You teach. If any entrepreneur we say, they learn from any of you. So teaching is an excellent service, and learning is teaching is godliness. All of you do. I wish all of you good success in your area of service. I had one video. If there is possibility, I can show. Otherwise, open for questions, or the anchor can say. I request Professor Jayakumar also to speak few words on what we did. If he is online.
Sir has raised his hand.
So you can.
Sir, you can unmute and speak, sir.
I also have a video. If we have time, I can show. Otherwise, open to questions. Yes, sir.
Am I audible now?
Yes, sir. You can give
Yeah.
you can give a summary, sir.
Yeah. Professor Velingiri, sir, thank you for your nice presentation. Friends, one or two points that I would like to highlight is teaching is a service. For example, it is completely different from manufacturing. And of course, when we say teaching, multiple teachers teach at multiple places. So there is always difficulty to maintain standards. Whatever Mr. Vellingiri sir has shown us is quality related issues. It is not only in manufacturing, even in teaching also. For example, when we say somebody is a good teacher, the X is a good teacher, Y is not so good. What is the challenge as an institution? We have to set certain standards. We have to create certain quality standards. Whether it is 7QC or 5 years, it has to be probably adopted at the university level, right from the student admission, right from the student's assessment. There are a lot of variations. Even in OBE, we talk about rubrics. Rubrics is also one kind of a probably standardizing our assessment. Whatever quality he talks about, it is applicable not only in manufacturing, even in service industry also. In fact, it is more useful for service industry because a particular paper, say R programming, is taught by many teachers and it is also repeated for many years. And we use different kind of teaching learning materials and we use different kinds of assessment tools, question papers. So we have to necessarily go for standardization. One example he said about the framing of the syllabus for BSc manufacturing. At every stage, he gave a lot of examples related to industry. So ultimately, we were able to really identify the right kind of courses. When we talk about a new program, especially manufacturing area, we have no standards, we have no model, previous model. He focused on 3 the mindset or attitude. The quality, it is not a skill. It is not only related to knowledge. It is kind of acquiring a new kind of a mindset. For example, wastage of time, wastage of products or less time. No, he talks about Vellingiri. The same also in teaching learning, especially in the teaching delivery methods. We have to now borrow many things. For example, you need not create any material. You can borrow materials from elsewhere. In that case, we have to ensure the quality, whether it is up to our expectation. So earlier in my lecture, I said about the knowledge creation, knowledge configuration, knowledge curation. So the quality, he took only one aspect called quality and he generated knowledge and he configured and finally he curated. This is the process we have to follow in all our papers, whether we teach, whether we teach prose, poetry, or whether we teach physical education, or whether we teach physics or chemistry or total quality measures. In all those areas, we have to work with the students. Every aspect should be taught thoroughly and every aspect should be practiced inside the classroom or in the lab context or in the production context. That is what he highlighted by giving a lot of examples. 1 or 2 important things he highlighted is interactive teaching learning material is very, very important thing. And even complex concepts can be really given through simple visual pictures. And he also emphasized a design thinking process. And he also emphasized adaptive learning, sense making, and learning across multiple cultures, learning from Japanese culture or learning from Chinese culture, especially manufacturing related activities, or for that matter, teaching learning process or conducting research. He gave a lot of examples. Only thing is how effectively we are going to adopt inside our classroom when we revise our curriculum or when we revise our lab practices, which is very, very important thing. And he also emphasized innovation, which is very, very important thing. For example, he says that in Japan and few other Asian countries, every year they come out with a new product. Even a particular product is well received, has a huge market. still then they come out with a new product in this by the same industry. The products compete each other by the same company, produced in the same company. And similarly, we also should really create new courses. And each course, we have to create both internal competition and external internal competition means the mechanical engineering department should come out with extraordinary courses and it should compete with, say, electronics department. The electronics should compete with some other, say, EEE department. That kind of internal competition is very essential, and external competing with nearby colleges. Both of them are essential. He gives a lot of examples. I sincerely thank Velliyangiri sir. We can use him for ensuring quality service, quality delivery. Thank you, sir. Thank you very much.
Thank you.
Hello. Hello.
Sir,
Yes, sir. Yes, sir. I think
Sir,
questions, both of us can start. To,
Yeah.
There is any question.
I am available.
If it is more on academic, your answer will be more apt.
Sure. We will invite questions now. Madam, we will invite questions now. Madam Coordinator, we will invite questions now. Participants can raise questions.
2 questions are there on the board.
Yeah. Velliyangiri sir, look at the madam. Can you read out the question first? If
Is
you
an
don't mind.
innovative curriculum effectively benefited to the School of Commerce? That was the question by Dr. Balasubramaniam.
Innovative questions, innovative program for.
Is an innovative curriculum effectively benefited to the School of Commerce?
Okay. No, I think in my presentation, I have given you 1 or 2 examples day for yesterday. Friends, look at the services of the bank now. You carry your bank with you. And the banking service is completely dominated by technology companies. And now you have differentiation of functions. For example, you have a separate payment bank, payment gateway, payment bank. You have varieties of hundreds of services, and by segregating the banking function, and the technology company play also the role of the bank, some part of the banking function is carried out. Now, the major challenge is providing customer delight, customer satisfaction, so that you have to really provide personalized banking service. The next one is introducing technology so that you instantly, by sitting anywhere, any place, anytime, you have to do your bank, you have to do your probably banking related service. You have to draw the banking related service. The third one is the security, which is very, very important thing. Now we are talking about blockchain. So now the commerce student should know what is customer segment, customer's delight, and he has to use varieties of technology tools which will function, which will differentiate various functions of the banking or commerce, trade, or anything for that matter. And they should also look at the, say, for example, by using the data available with them, they can go for data analytics so that in a very, very minutest sense, you can support the customer or you can support anyone who coming to your commerce or trade activity. So the data analytics, technology integration, and understanding the data security, and also provide them how you can create a wow factor. It means when I say wow factor, a person can look at your service and he should really price you. Oh, you have a new service now available, which is not there in the other bank. That kind of an innovation every day, every year you have to create. So think of banking 24/7, personalized technology, safety, data safety measures. All those things are new functions. Our traditional commerce functions, traditional commerce curriculum is essential, but appropriately integrate with technology is very, very essential. I'm just giving you only a small sketch. Are you satisfied, sir, Dr. Balasubramaniam? Are you there in the group now?
Yes, sir. They are
Dr.
in attending.
Balasubramaniam? Okay, fine. We'll take the next questions, madam.
Also, it is in, I want to operate my accounts, finance, banking details in my hand with a mobile. So everything is possible. I download statements, give it to income tax. I keep download monthly account, store in a file in mobile. So it is in my fingertips.
Correct.
Yes, sir.
So adapting technology.
Next
Multiple
question is
platforms.
by Swati Rajendran. Sir, can you briefly explain about plant internship in Kaizen, sir?
So this is problem solving technique. Kaizen is changed for better. Again, from evolved from emerged from Toyota production system. Kaizen pioneered by Masaki Imai. There are many books. Kaizen is to make improvements. We can make it is small improvements. If Six Sigma is or high level of innovation is a big jump, Kaizen is small jumps. So we there are 7 steps of Kaizen: problem identification, then problem analysis, root cause finding, then solution countermeasures, solutions finding, implementation, then check results, improve, horizontal deploy, then standardization. So this we normally simply we use ECRS and 7 Kishi tools for solving problems. So this is a method we have in companies. It is monthly Kaizen competition. Even in Tata Electronics, they have lean Kaizen every month.
Yeah, true.
Improvements teams participate. Then we evaluate and give some suggestions to improve. It is on a monthly basis. So if we can teach in colleges, NTTF is teaching. Maybe, I don't know, some colleges may teach this. Lean is in part of mechanical engineering, I think. So part of Lean, they may teach Kaizen also. It is possible easy.
Next question is, we make elective subject as an industry approach. What are highly benefit we can achieve through that, sir?
I said students are not industry ready. So for industry ready, the visit to plant industry visits, only thing you should ask a learning diary, or when they visit and come back. You can even have MCQ, frame MCQ learning points, then it will be registered in their mind. We ask if they make plant internship, we ask a learning diary report.
All right, sir.
Yeah, administratively, I can suggest 1 or 2 things, madam. One is right now UGC, AICTC are encouraging process of practice. So you can take, those who are in the industry experts like Velliyangiri sir and whoever you know them better. You can take them as process of practice. They can come and teach 1 or 2 credit courses, especially the value-added courses. That can be part and parcel of your curriculum. And similarly, instead of going for a very, very bigger industry or probably very bigger manufacturing companies, even smaller SME will also be a useful place for you to learn many things. So don't just look at bigger industries or bigger companies. You can even take small SMEs or in an old region, and you can take the industry experts as process of practice. And in fact, in some of the institutes, autonomous colleges, I know engineering colleges, the question papers are set by industry experts. Please take it from me, it's a very serious thing. The question papers or internal assessments are not created or not really drawn by the same teachers who teach that course. The assessment tools and methods are given by the industry experts. So this is another way you can think differently, and so that the students or our teaching and learning process is very close to the industry demands. Madam, next question, madam.
Yes, sir. Next is Dr. Nalini have asked, which industry is known for the quality in India when compared to other countries? Which industry is known for its quality in India when compared to other countries?
It is almost all MNCs, also all automobile companies, all electronic products. Yes. So Titan itself, HMT was there before. Titan came into picture. Then where is HMT now? So it is because of quality. Quality is not one dimension. Professor Jayakumar used to say 8. I put 10 dimensions. It is more features. Apple is known for mobile phone for quality. ICICI Bank is known for quality because banking is in your hand. So it is not just manufacturing, automobile. It is products, electronic products. Now EV some issues, they have to improve. So it is almost all big industries where they have more competitions. Quality is the only method to survive. Titan was a jewelry. Titan jewelry successful parameter was quality of jewelry. Before that, it was not 22 carat. It was 2018, 17. So Titan introduced carat. So Titan not only improved quality of Titan jewelry, Tanishq, it improved the jewelry of the entire industry.
True. And Tata Steels are another best example. For example, in steel, Tata Steel is a good example.
All Tata Group companies, quality first.
Yeah, true.
There are many automobile companies.
Yeah.
Even if it is one car, the Cyrus Mystery accident, the manufacturer came to India, studied. So they check. I stayed yesterday in holiday in Dover yesterday. Today I got a call, the feedback. Car service, every Toyota car service, they collect feedback on next day.
Yes, sir.
About the
Yes, sir.
service, hotel industry, car industry, automobile. Titan gold watch servicing is lifetime. It is considered as quality, not just product quality.
So all the industries are towards quality.
Yes,
We can conclude like that.
yes. If it is
Yes,
like in India, quality is the prime mover.
True.
Yes, sir. Okay.
And
Next
any
question is
participant?
from Vidya Rani.
Yeah, go ahead.
Sorry.
Go ahead.
Good products are manufactured with the good raw materials, but the students who are get admitted in arts and science college are not up to the mark. How to shape them as an industry ready product? I'll read the question again.
Entire session is the answer. It was to make industry ready BSc Manufacturing Science student.
Madam, I also have an answer.
You want me to read the question again?
Yeah, I also have an answer. For example, we have some preconceived notion. Do you think that students from engineering discipline or students who are admitted into some professional colleges are extremely motivated or extremely bright? No, it is not really so. Please understand, we have certain difficulties. The intelligence, motivation, or initiative, they are all controlled by several other external environment. External environment means environment of the students, parents, the way where the way in which it is taught. All those things are very, very important thing. It is a long drawn process, and let us not really think of certain negative things. And probably these negative things are there everywhere. It is there in, at least I personally seen in my own experience outside the country. I was a full-time faculty in the University of Michigan, Ann Arbor, one of the top 10 countries, top 10 universities in the world ranking, D ranking or QS ranking. It will come within 15 ranks. But please understand, there also we have non-serious students. Please understand, emotionally you have to make an appeal to the students and let them learn bit by bit. And it may take 2 or 3 years. Don't worry about that. Continuously work towards that. And maybe after a year or so, or after 2 years or so, this seriousness you can inject in the minds of students. Make learning as an interesting thing. Make learning through games, or make learning as a team. So that once if their interest is, if they gain interest, or if they acquire interest, these kind of issues, certain basic issues, can definitely be solved. I have that positive note within me.
Okay, sir. Next question is Sahu. How cloud commerce work in today's scenario? That
No,
I
sir.
think you have already answered those.
This
Yeah,
was
yeah.
answered. First,
You in your session, I think.
Yeah.
first question, even now he answered. First question.
Yeah.
Yes, sir.
please,
Next
uh,
is Dr. Jayavelu has asked, in what way mechanical engineering be more competent with the other stream? In what
very-
way mechanical engineering be more competent with other stream?
Velingiri sir,
Even-
please.
Even in electronic parts, manufacturing is through mechanical engineering process. So even an electronic industry need mechanical. In fact, we developed manufacturing engineering combining mechanical, also selective subjects of electronic parts manufacturing, electronic manufacturing technology, surface mounted device. Also all these 5S, 7 keys tools, Lean practice, Lean Six Sigma, we incorporated.
Next question is Ms. Asha has asked, sir, can you cite some example of implementation of Six Sigma in physics discipline?
I think electronics came from physics. That's my my own.
True.
Yes.
Because there are electronics professors in engineering, also in arts and science college. Both talk about electronics. So why not? Even other branch. It is possible.
Yes, sir.
Only thing,
We will
incorporate the subject accordingly, then do. Manufacturing science, the course we incorporated considering some of those points. They are not industry ready. So why not why not they read drawing, why not they understand problem solving tools? So you try to check wherever they work, understand, then you can incorporate relevant subjects, add 1 or 2 subjects.
I think we will wind up with the last question because few or more questions are there. I'll just read out the questions. How could we identify the problem in curriculum and when have we to change it? Dr. Kannan, assistant professor, have asked us.
The one example I will quote, it was an actual problem during the curriculum development. We used to collect feedback. We had a brainstorming on one of the subject, CNC machining milling. To our surprise, during the discussion, the feedback was the textbook was 20 years back old. 20 years old. So the machine is getting updated every year. 15 years old textbook. Then the team said, no, we should not accept this. And we want this for CNC, safety, operations, precision milling, then programming, online maintenance. So we updated. So study the syllabus, test the syllabus. It is part of design thinking process. So you show to industry experts, subject matter experts, or ask your students, call back your students working in such companies where they are expert, then collect feedback and incorporate.
Yes, sir. Next question is Pramila. How do we incorporate today's concepts in civil engineering?
It is similar answer. Civil engineering ready to make the concrete Tata Electronics housing is done by ready to make. There are prefabricated structure. So they bring and incorporate. Chennai Silks did this in Hosur. Is it part of the subject? There are more rainy season in the last 2 years. There are more complaints. Infrastructure. Is there a solution in the subject already in the textbook? If not, update. Look at the current problems. 10 years back problems may not be there today, but there are new problems. They want to construct faster bridges, houses. It is a prefabricated structure for Chennai Silks, I know in Hosur. They did it in 45 days, entire building. Prefabricated structure going to be used for housing for Tata Electronics. All because of raining, there are hundreds of problems across country. Is there a learning for to incorporate subject in the civil subjects? I interacted with a civil expert in Hosur. I asked him for a college, if I go for a discussion, I need to understand. He said roof leaking during the continuous rain, they're not able to address. So he gave some solutions with learnings from Swiss industry. So he was saying this should be incorporated. So there are learnings. First, look at the problems in the country, then look at what is available, what is not there, find the gap, the same model which I have shown in one slide. So you
Yes,
check step by step, adapt, consider.
I think we can wind up today's session because it's past the time.
It is surprise for me, 9:03.
Okay.
Thank you.
Thank you.
Thank you, sir. Yes, sir. Yes, sir. We thank you, sir, for sharing your industrial expertise on quality delivery. So when we measure, we understand. When we understand, we control. When we control, we improve. When we improve, we achieve. Thank you, sir, for your intriguing and interactive PowerPoint slides. It helped us to understand the gap with the industry quality process. Thank you one and all for attending this FDP session. I wish you to relax today and we will meet on tomorrow's session. It's Shanti signing off. Thank you.
Sorry, it was like industry slides.
No, sir, those slides was very interactive, intriguing actually.
I wanted to
Intriguing
be different.
slides. That's what I want to mention it.
Purposely, I
Those
wanted
slides
to be
were very
different.
nice.
Okay. Thank you.
Thank you,
Thanks,
sir.
sir. Thanks, Professor Jaykumar also for supporting me.
Thank you,
Because
sir. Thank you
he's
also.
an academic
Thank you.
expert. Thank you. I'll exit.
Sure, sir.
Thank you.